My example today for my presentation is going to be reflecting a vector across a generic line. So here's my generic line, and I'm going to call that my y equals ax plus b. And I'm going to take some random spot here, and I'm going to reflect it over that line and put it here. So this is going to be my vector xy, and it's going to find a new home over here at x prime, y prime. Now the easy one to do is a reflection across the x-axis. So if we were to get this point and reflect it across the x-axis, that matrix is super easy. So that's a reflection, 1, 0, 0, -1. So that keeps my x values, but then flips my y values for the reflection. So I want to pretend that this line here is going to be down here so that I can do the reflection. So that looks like we need to do a rotation. So I'm going to rotate this thing down. So our rotation matrix is going to have cosine and sine with a negative sign here and another cosine there. Now, if you're paying attention, this is a positive rotation. I don't want to go in the positive direction. I want to rotate this down. So I'm going to take a negative, or not a negative, an inverse, right? So I can get the rotation going in the right direction. We're going to switch up these cosines and then switch up the sines. And normally we would check the determinant to make sure everything's good. So cosine times cosine, cosine squared, minus the sine squares. So that would end up being positive. Cosine squared plus sine squared makes 1, so we're good. So this rotation, inversely going in the opposite direction, is what we're looking for. Now, when we do that rotation, it's actually going to be floating up here, and this is a point of rotation. But I want that point down here. So we're going to do a little slide of -b. So this is why I picked this example, because we got a little bit of reflection, rotations, and a slide. We're doing all the things. All right, so let's put this all together. We're going to take our xy vector, and we're going to slide it down. And we want it to be on the origin when it rotates, right? So this is our little slide. And then we're going to do our inverse rotation. So it's going down. We're going to go sine, cosine, cosine here, and negative sine. So this whole bit right here, I'm going to highlight it. This whole part is to pretend to be the x-axis. We moved all of the vectors and everything, so it's down here, so we could do our reflection. So our reflection matrix is going right here. 0, -1, 1, 0. So this was the whole point. This is the reason we're doing all the things. So we're reflecting across the x-axis. We moved this line, slid it down, and then rotated it and pretend it's on the x-axis. We're going to do the reflection. So now we got to move it back because that's where it actually is. This is just pretend, so we got to move it back. All right, so let's move it back. I'm going to pick a different color. So that means we're going to move our rotation back up. That means we're going to do a negative sine theta, cosine theta, cosine over here, and another sine here. And remember the little slide. We got to scooch it back up. So I'm going to scooch it back up, our little slide. And I'm going to highlight that so we remember what we're doing. This whole thing is to put it back. We got it? We got it all? So we're pretending this is the x-axis. We're moving this down, and we're rotating it down so that it's sitting on the x-axis. Do the reflection. Now that we've done that, we're going to scooch it back up, rotate it up, and put it back. Now let's do some math. So first, we're going to do the stuff in the parentheses because PEMDAS, right? So I've got x, y minus b. And then just to make it easy, I'm going to take this stuff and stick it at the end because that's an addition which happens at the end. So I'm going to call this my last bit. This is the last bit I got to do. All right, so let's copy some of this. We're going to do this part right here. So I'm going to be going left to right. Now these are all 2x2s, so it's not going to change anything. This is all not commutative but associative, so I can do these in any order. It'll be okay. So cosine times 1 is cosine plus sine of 0. So that's 0. Oh, right here. So just in case we forget. So we want to do our rows first and then our columns in the second. So second row, first column. So sine times 1 is sine. And then cosine times 0 is 0. First row, so I got cosine times 0, and then negative sine times -1 makes it positive sine. Second row, 0, and then cosine times -1 makes it negative cosine. I'm going to copy down all of this, ready for the next bit. We're going to multiply these together. So first row, first column, I'm going to get cosine squared, and then minus sine squared. Next up, sine cosine, plus, oh wait, negative and negative make positive. No. Yeah, negative and negative make positive. So we've got sine, cosine again. Give us some space. Next up, first row, second column. Cosine times sine again, sine cosine, and then sine and cosine again. So it looks like we got the same thing. So I'm just going to do a little sneaky simplifying in here. So that's 2 sine cosine. And then the second row, second column, so sine squared, and then subtract. We've got minus cosine squared. And then I'm just going to copy this down just to keep it clean. All right, plus 0b. If you've been paying attention, we've got all this theta, but I've got y's and b's and x's. So what we want to do is get it in terms of a. So I'm going to throw this into a really quick triangle, and all of this is going to be theta. A is a slope, so this is rise over run. So our rise is a, and our run is 1. Pythagorean theorem, we're going to get ourselves an a squared plus 1. And now we can rewrite all the things. So now this is sine theta is equal to opposite over hypotenuse, a squared plus 1. And I got cosine, that's going to be adjacent over hypotenuse. All right, so now we can put all that in here and stub it in. Ooh, I'm going to give myself some space. All right, so first up is cosine squared. So I'm going to take this n squared. So I got 1 over a squared plus 1 minus sine squared. So that's a squared over a squared plus 1. Remember, all of this is simplified here, so I'm going to do that. So I'm going to get 2 sinus a over square root a squared plus 1 and cosine. Oh, look at that. It's the same thing. So 2. I'm going to do some sneaky simplification here. So when we multiply the bottoms, the square root's going to go out. So let's put 2a over a squared plus 1. And then this is the same, only flipped. So now this is a squared minus 1 over a squared plus 1. All right, now we've got this all in terms of a, and we want to multiply this by y minus b and a little bit. So when we multiply, we want to take the whole first row times the column, and then we end up with a 2 by 1 at the end. All right, more math, here we go. So now I've got x times all of this. So remember, all of this is simplified right here. So instead of a squared minus 1, this is 1 minus a squared over a squared plus 1, plus, we're going to take the bottom times this thing. So we've got y minus b, and all of this, 2a over a squared plus 1. So this is all one row. Second one, remember, this is simplified here. So I'm going to take x times all of this, 2a over a squared plus 1, plus y minus b times all of this, a squared minus 1, a squared plus 1. Getting messy. All right, there we go. Oh, did I forget? I did forget. I got to put my little extra. So I'm going to put my little bit. This is where I'm going to put it. Plus b. There it is. Looks good? So this is all for our new home, x prime, y prime. All right, and I should have put it right here. So under equations, see, I typed all that stuff in. And when you move your point, nope, that's not it. This is it. Oh, it reflects. Look at that. So all of that I just showed you, I just typed it in here, even with the little plus b at the end. And it shows our reflection. Not that one, this one. Cool, right?